Well, good morning. I'd like to welcome everybody to another TFP discussion. This one's on pool pumps, filters, and heaters. Joining us today is Jim Rabe, as known on the forum. Jim, AJW22, or Alan, as known on the forum there, and Mark, MAS985, is known on the forum. We're going to have a 1-hour discussion around pumps, filters, and heaters. Probably focus a little more on the pump side of the business, just because there's a lot of changes coming in the industry around pumps. Remember, we're not going to get into specifics here, so we're going to, anytime there's really specific items, feel free to go to the forum, post a question, and/or use the wiki section in the forum. Chat is open. I will be monitoring chat for all those that are visiting, and we'll bring up any pertinent questions from chat as we go along. So let's go ahead and get started. So around pumps, there's types of pumps. Mark, could you give us a quick summary of the different types of pumps that are out there for pools?
Sure. I'll use the definitions that the government now uses because of the new regulations, but there's three general types that they classify as: single speed, 2-speed, and variable speed pumps. And as a subclassification, they also identify as self-priming and non-self-priming. They don't use the above ground and in ground anymore, so that terminology is kind of getting phased out. But in general, those are the three main types of pumps. And obviously single speed is a pump that operates in only one speed. A 2-speed has 2 speeds, 3450 and 1725, and a variable speed, of course, is variable speed, usually all the way down to 400 or sometimes less RPM, up to 3450. And again, the two subclassifications is priming and non-priming. Generally, in-ground pools will use the priming, self-priming pumps because they're installed above ground, above the water level, I should say, while the non-self-priming pumps are generally used for above ground pools, because they're installed below the water level and they don't need priming. Although there are some above ground pumps identified as above ground pumps that are self-priming. So that's kind of an overview of that.
Great. So going forward from those types of pumps, and again, we're not going to focus on booster pumps and all those other things, just the primary filter pumps. Sizing of pumps, I mean, that's something that's always drawn in. People come in on the forum and say, oh, I have to have a 1.5 horsepower pump for my 3,000 gallon above ground pool or some crazy thing, right? So I guess let's focus a little bit on sizing and how many times pumps are well oversized, and also how we'll be sizing variable speed pumps, if you could, Mark.
Yes, I think a lot of that's going away because of the regulations. You're not going to have much of a choice anymore. So in general, and it's probably a good thing, people really get, I think, too wrapped around, what's the best size for my pump? There really isn't one, especially when it comes to variable speed pumps. Those will fit any pool. So if you just want something simple, just get a variable speed pump and it'll solve all your problems. And in general too, that in most pools now with spas and water features, they're going to have variables now as well, due to the regulations. So that's going to really push the industry towards that. There are going to be some cases where you will be able to use a smaller, say 2-speed pump if you wanted to, pool, and be able to choose a size there. But again, because of the limitations and the regulations, you're not going to be able to choose ones a larger size. You're going to be limited to smaller versions of that.
And along those lines, I've downloaded here, and I may end up seeing if we can put it up on a wiki somewhere. Maybe Alan can help me with that. There's a couple of really good documents out of the Pentair website, not focused on Pentair, but I just found them on their website that does discuss the DOE regulation and also
Right.
the different aspects of that.
If I could I share my screen? Would it be possible to do that?
I have to let you.
I'm not sure which one. I got 3 screens, so I'm not sure where it's going to show up. We just, can I do that?
Yeah, I think you can. I got it set up where anybody can share, so.
Oh, let's try it. Did it work?
You got it.
Okay. On this, I felt this was a really interesting graphic that kind of shows the layout of the whole regulations and everything. And it really and succinctly describes really what's going on and what's being regulated and why they chose the levels they did and all those types of things. So basically, these are all the pumps, I think, in the US market, all self-priming pumps in the US market. And they're plotted by hydraulic horsepower versus weighted energy factor. And both of these terms are what the government's using now to determine whether a pump is compliant or not with the new regulations. So basically, you can see the single speeds are way down here because they have low weighted energy factors. The dual speeds are a little bit higher, and then the variable speeds are much higher. And so for this, and you see a demarcation at 0.711 hydraulic horsepower right here. And so anything below that has a different requirement curve than anything above that. I think you've seen probably in different websites that anything below 0.711 is fine. Well, that's not exactly true. There's still a requirement. You can still see some single speed pumps will be below that level, and so they will not be compliant. Some manufacturers have already indicated that they're going to work on these designs to pull them up above this line and redesign them, but I don't know how motivated they're going to be given the market. Now, I think the market share in this area is probably going to be very small. But anyway, this also shows the new requirement above 0.711. This is the new WFE requirement, and you can see that it bifurcates right between VS pumps and dual speeds. So that's not by accident. So basically what they've done is gone through and excluded all dual speed pumps as being energy efficient, which to me is a little extreme, but because many of these would save quite a bit of energy, even though they don't allow those anymore. So the market may move in trying to create dual speeds above this, but I think what's going to happen, and we've seen it in Hayward pump line, is they're starting to make some variable speeds that are pushing cost envelope of dual speed anyway. So they're looking at multi-speed pumps that don't have a lot of control. You can't use a controller to interface with them. So they're kind of reduced functionality, if you will, but the price points are expected to be fairly similar to dual speeds, or somewhere in between dual speeds and variable speed pumps. But I think that gives you a kind of an overview of what's going on here and what they're changing. This line's important too, because nothing above 2.5 hydraulic horsepower is actually being regulated, although there really are no residential pool pumps that are in that area anyway, so it really doesn't matter.
Great. Well, that's very descriptive. I think that's a great view that tells us the differences that are going to occur. You can go ahead and get that down. Great, thank you. Yeah, so I mean, around sizing again, I think, you spoke just specifically of self-priming pumps. Above ground pools primarily have, non-self-priming pumps. And so many people have said, oh, they're not going to be included in this regulation, which I believe is untrue. That's
untrue, yeah. They are being included, although it's not shown on that, wasn't shown on that particular chart, but their curve is actually well below the one for the single speed pumps, or the one for the hydraulic horsepower below 0.711. So they're giving a lot of relief to above ground pumps. And I haven't looked at the data myself to see how many are above that requirement, but I think most of them, if not all of them, are. I think they've deliberately created the requirement such that it already includes most above ground pumps, because most of those were pretty small to begin with. So I don't think it's going to be a huge issue. But I mean, for those people trying to choose that particular size, I think that in most cases for an above ground pool, the smaller the better in terms of a pump. If you can find a 2-speed in 1 horsepower, 1.5 horsepower, that's probably all you need.
Right. Great. Jim, Alan, any comments before we run to troubleshooting real quick here? Unmute yourself, Alan. Hey,
one thing that's not clear to me is we're talking about when you go replace a pump, replacing a motor on an old pump. Will people be able to buy 1 horsepower, 1.5 horsepower Century motors
Right.
forever, or do these regulations also limit the sale of replacement motors?
That's a great question. And the answer is we don't know. It looks like the legislation is coming next year for that. And there's some musings about what it's going to include. It looks like it's going to have a limit on single speed again, on how big they can be. But California right now does have requirements. Anything above 1/2 horsepower has to be a BS replacement, basically. So they've already jumped the gun, which they always do. They did these regulations well before the federal government did. But right now, according to some of the motor manufacturers, it looks like the ruling is coming in 2022. But we'll see what happens there. But I think that's a good point. Is that they'll probably will limit how large a single speed pump is. They might give you some. One of the concerns I know was that when a VS fails, do you have to replace it with a VS motor, or could you use, say, a 2-speed motor? And I think that those are the things they're trying to work out right now.
great. Yeah, it's I noticed that in California, made in Inyo Pools' website. If you go ahead, it says everywhere that you look at replacement motors and everything else, not Title 20.
Right.
Right.
Right. And I think the government, U.S. government too, these new rules, they're affecting manufacturers only, and not stores and retail outlets and those types of things. So technically, manufacturers could continue to produce all these pumps, but just not sell them in the U.S. They could sell them other places, and then they'll have to mark them as not for sale in the USA. But.
So we may have some confusion on the forum with some of our international folks when we bring up these things. We have to be reminded of that, especially even Canada. I don't believe Canada has these regulations.
No, although they do recommend Energy Star pumps, which is a U.S. thing. So I think they might be close behind and following what we're doing.
Right. Well, that's great. So on to troubleshooting of a pump. Now we see lots of different things brought up on the forum about troubleshooting, whether it be the motor has a problem or the pump itself has a problem. Alan, give us some of your top 3 or 4 troubleshooting items that you've seen on the forum, and run us down on some of those
items. Okay, now I'm unmuted. Number one thing that we see a lot of is pump capacitors. And, they're clearly a weak spot in a lot of pumps. It depends upon the type of pump. There's what's called a start capacitor, a run capacitor. And so when a pump just hums but doesn't start spinning, The humming means you got power to the pump, and it's often the capacitor, that blue in the capacitor is on that, often on that hump at the top of the motor. So that is something easy to check with the multimeter. If you have a multimeter that can do capacitor checking, and that's often the problem. The other problem is simply no power to the pump, and could be the circuit breaker, something electrical. And the third thing is the pump just corroded out from water leakage from the front seal getting through the shaft into the motor, causing either GFCI trips or the pump not to spin up at all. Those three, I think, probably cover the vast majority of what we see in pump problems.
What about, I've seen a number of impellers, especially in the spring. People have impellers plugged with pine needles or some other material, and it pushes itself out as being very low performance or very low flow. Is that correct?
Yeah, and it's interesting how much stuff gets sucked through your skimmer and the pump basket and through the impeller, and eventually it ends up in your filter. And depending upon the setup, some people have broken skimmer baskets or filter baskets that let larger pieces through, and that's often why things get hung up in the impeller that impedes the flow through it.
Right. Right. Also, we see, and again, we call them leaks, but really they're a pump problem, are the air leaks around the gaskets, the pump drain plugs, and things like that. The one item that I think a lot of homeowners don't realize is having a good pool lubricant, a good lubricant that's designed for gaskets and things on the pumps. And so in the wiki, again, there's a really great description about pool lubricant. Woody brought up the idea of being able to change your impeller size to increase, decrease flow. Now, my understanding is that the motor can be bigger than the impeller rating, but not the other way around. Am I correct on that, Mark? Unmute yourself.
There we go. I got it this time. All right. So yes, that's true. You can reduce the size of the impeller, but you can never increase it as long as you have the same motor. You can actually what's called trim impeller, which means you just trim down the diameter of it. This has a similar effect as changing speed on a variable speed pump. In fact, it's almost identical to that. So if you have the diameter, you have the flow rate through the pump. Of course, you can't increase it after you've reduced it, so there's a problem there. But if you want something easy and very cheap to do, and I've done it before, is you can trim down the vanes in the impeller and get lower flow rates and less energy use.
So you don't have to worry about going unbalanced?
Well, yeah, you do. So you do have to be careful about that. So what I did was actually use the motor itself as a lathe. Basically ran the motor and took a file and just ran it along the bottom of it and slowly reduced the diameter. So it was rotating the entire time to keep the symmetry and the balance of the impeller. And then if it's out of balance right away.
And you would know. Yeah. Another question that's popped up here on chat, why must a pump be connected to a GFCI breaker? The old regulations didn't require that. Anybody help us on that?
Well, I can take it if you want.
Okay.
It's safety. I mean, that's the bottom line. It's much like why are there breakers in general? It's to cut the power off. So if it's a GFCI basically measures the current along the two paths. It can be along a 240 path on each of the legs, or it can be off a hot lead and a neutral as well. And if the current deviates too much, then it trips. And basically the thought there is that if it does deviate, it's because the current is traveling somewhere where it shouldn't be. And so that's primarily why they're using them now.
Okay, great. Anything to wrap up us on our discussion around pumps? We were actually a little quicker than I figured, but Mark was very prepared on the federal regulation side. Any last items anybody has? Alan, Jim, Mark, any of you, just pop up and let me know.
Well, since we have a moment, one of the things we're seeing on the forum is pump size in relationship to spa jet flow. And, it appears that a lot of pool builders do not understand the flow rates that the customer is expecting to get for a good spa massage, and what a pump can deliver, particularly when run through a filter and heater. In my case, in my spa, I have a dedicated spa jet pump that is not restricted by running through a filter or a heater. It just pushes water right through to the jets, and I get really good flow. With the new VS pumps, because a lot of them are 2.5 to 3 horsepower, they're now being used for dual use, for both providing to the pool returns, but also to the spa massage jets. And we're seeing quite a few folks who are disappointed with the flow rates they're getting and the effectiveness of their spas, because they just can't push the amount of flow through a pump that's running through a filter and a heater that may be a gas heater or a heat pump. So that's something I'm just mentioning for people listening. If you're putting in a spa, it becomes more important paying attention to some of these pump design factors to make sure you're really getting what you're expecting from your spa jets.
Great. Hey, Diane has popped in with a question here, a comment, basically says she's seen some instances this year when someone bought a larger horsepower replacement motor and thought they bought the appropriate impeller, but ended up with a seized motor or destroyed impeller. Is this an instance when the service factor is more important than the stated horsepower?
That's possible. It's definitely a mismatch if you're seizing the motor. Normally, though, most motors these days have thermal limiter switches in them. So if you do put a smaller motor on a bigger impeller, what'll happen is it'll keep shutting off every 10, 15 minutes. And you know right away that you got a mismatch. It's self-protecting, basically.
My understanding with the federal regulation coming up too is the service factor, the SF factors put on almost all single speed pumps goes away.
Yes, the whole thing goes away. They're mandated to now label everything with THP,
Right.
total
It's
horsepower.
gotta be THP.
So service factor and the label horsepower and all that's going away. So all those on the forum that have been wanting that for years have their wish now.
Yeah.
So,
Yeah, that has been an interesting discussion. People come on and go, well, I have a 1 horsepower pump, and you look at their service factor and it's 1.8 or 2.2 or whatever. You're going, no, you don't.
yeah, in fact, actually, Pentair said that they're going to also put not just THP, but they're also going to put the hydraulic horsepower on the pump, the value that's used for the WEF measurement. So.
That's fantastic. Yeah, again, like I said, I believe these Pentair documents somehow we try to link to them in a wiki of some kind. Maybe we need to put one together for this federal regulation.
Yeah, I was going to suggest I have a bunch of links to the government documents if anyone wants to get into the weeds. It actually lays out the entire thing and how to how to do the measurements and, what the impacts are. And
Right. Great.
pretty good
Yeah,
information.
just talk for a minute, talking about that pump impeller mismatch. Overheating pumps. And Mark, is it fair to say that, a properly operating pump, you should be able to put your hand on it and not feel burnt? We see
Yeah.
a lot of people whose motors are running hot, and it's really indicative that they have some problem that if they got on early, they could probably save that motor and fix that pump.
Sure. Although most motors actually have a very high thermal rating on them, so they're measured up at 140, 150, and so that's really hot. I mean, you can't put your hand on it very very long, but so they have very good thermal insulation in them, so they can tolerate that real high heat. But that's why I say the thermal limiter will usually tell you right away, assuming it has it. And I think most motors have them now. There's maybe a few above ground pumps that really cheap motors that don't have those, so they should cut out. In fact, when a capacitor goes bad, it should also behave that way where it cuts out, because if you leave it running with it just stationary, the rotor stationary, it'll heat up very quickly, so it should trip that.
Quick question here from Judson. Besides cleaning the filter, emptying the pump basket, and occasionally lubing the O-rings, is there any other regular maintenance that should be performed on my VS pump?
Well, one thing you should always look for, and we've seen this so many times in the forum, is if the seal starts to leak, because a pump motor can go bad very quickly if that seal is leaking, because it's right down the motor shaft, and it goes from the impeller, the motor's right here basically, and if it leaks in, you get right into the bearings, and those rust very quickly. So the important thing is really to detect those leaks very quickly, so you can save your pump basically. And those motors from the PS are very expensive, so you don't want to let those go too far. But sometimes it's hard to find those leaks as well. You really have to get down on your knees and look under the pump and see if you see any moisture at all. And sometimes the pump itself will leak, or you take off the lid and it'll leak, and so you can't really tell if that's a leak or not. But that's just something to look out for on a regular basis.
We hadn't brought that up. Great.
I'll also add, what's new with the VS pump is what's called the drive, which is the electronics, the brains that control the VS pump, that has a fairly complex control panel on it. Protect that drive. There is often a door that should protect the control panel from water getting in. And we see a good number of drive failures and problems with those panels. Those drives are unrepairable and very expensive. So, when you're looking at your pump, make sure that that door that protects, the cover that protects the control panel on the drive is closed and waterproof and weatherproof, because it's a very expensive failure.
You bet. Absolutely. Yeah. And in fact, in areas I would think where you get a lot of rain and a lot of moisture, et cetera, some kind of cover system over your equipment probably is not a bad idea.
I think we're going to be seeing more of that, maybe products for that, or sealing those drive control panels as VS pumps get into everybody's pools. Those drive panels may be the real weak spot in it. We'll have to see what the manufacturers do about them, because those covers appear to be pretty flimsy in terms of its water protection.
They're supposed to be NEMA rated, but we know how that goes.
Yeah, absolutely. Well,
one other thing I was just going to suggest too, and I do this with my own pump, but it doesn't have to be, it's not something that you have to do, but I try never to run the pump at 100% or full speed.
Right.
And the reason being is that you're dealing with higher currents, more thermal load on the drive and the motor itself. And anytime you can keep it below that as much as possible, the better off you are, I think. That's just my opinion.
You can adjust on all the variable speed pumps I've seen, the control systems, you can adjust priming speed, priming length.
Yeah.
All of that, you can set a max speed in them so that they won't ever go above that.
Mhm.
What you do, those kind of things, right? And
Right.
Jim knows, the control systems are the combination of the variable speed pumps and the control systems are the next step, I believe, in where we're all going to go. I know we've got a lot of folks, and we'll get into automation in another session another time, but we've got some folks doing some real home brewed kind of automation that way over my head, but that's also pretty neat. Let's move on. We've got a half hour, a little under a half hour left. We'll spend a little time here on filters. In general for pool systems, my understanding, there's 4 types of filters essentially, right? There's a sand filter that uses sand or some other fancy media that doesn't need to be used other than sand. There's cartridge filters that just use basic cartridges. There's DE filters that use DE on a wing type of media. And then there's what they call the hybrid DE. My understanding is kind of what they're termed. They're cartridges that use DE in them. I've had a basic old cartridge filter forever, so I don't have any knowledge of the other ones as far as operation. Jim, I know you've had 2 different kinds. Can you go ahead and give us some relationship on the different kinds of filters you've had and your experiences?
So I started off with a couple of rent house pools that have DE filters, and I at the time I liked them, and then I built a pool at my house, and they said I couldn't have a DE filter unless I run the backwash line to the sewer, which was darn near impossible. So I reluctantly said, okay, just give me a large cartridge filter. And now that's been about 7 years ago. And now I can't wait until my DE filters die so I can replace them with cartridge filters. I'm not so much, I don't know so much that there's any less work involved, but I don't have to mess with DE. I don't have to worry about the multi-port valve freezing up or not turning or leaking. I don't have to worry about where I'm going to backwash stuff. Anyway, I personally, if I build more pools, which I doubt, but if I was going to build another pool, it would definitely have a large cartridge filter. I like the fact that it has with a variable speed pump, if you're running a slow RPM, you don't have much back pressure at all. So you still get plenty of flow at a low RPM.
That's my experience as well. And if you look at the head loss of all 3 types of filters, cartridge by far has the lowest head loss. So you're going to get the best efficiency out of all 3 filters. Then comes DE, but the backwash valve is probably the biggest component of that. Those backwash valves are horrible in terms of head loss. And then when you get into small sand filters, that's even worse.
From a sand filter standpoint, I don't think any of the 4 of us have sand filters, if I remember right. Is that correct? But yeah, they're a fairly basic process. I think the biggest issue with a sand filter are problems with the internals, cracking or breaking or whatever for whatever reason, and then somebody putting lots of different potions in them that clog them up. And those are probably the only 2 major issues around sand filters. And in some areas, sand filters may be a very good idea from a simplicity standpoint, just because water's cheap. Dumping the water out into the field behind their house is no big deal. They do it every week. They don't even monitor it, and that's just kind of how it goes. I think in the future, though, I think we're going to see the evolution towards these cartridge or hybrid cartridge type filters just due to water use laws and things like that.
Yeah, Marty, with sand filters, one of the things I continue to see is the question of people using the right type of sand, that there is a specification. There's a wiki page sand filter use and care that goes through it and gives examples. But you can't just put any type of sand with particles of any size in the sand filter and expect to get the performance that it was designed for. People, particularly sand with smaller particles is the reason sand filter will blow out sand through the returns. So that is something that people with sand filters don't always realize, but the type of sand used in the filter very much affects its performance.
Yeah. Woody brought up a really good question, and really good, and it's something that I personally have not seen, and maybe one of you all have. Is there any kind of comparison charting or whatever that shows filtering ability between the size of the sand filter versus the square footage of a cartridge or DE filter? Did anybody ever see anything like that?
Well, I think between the three types of filter, there's in general, there's a filtering capability. In other words, sand filters, because of the media itself and how the particles fit together, a sand filter is like in a 20 to 40 micron size, and cartridges are half of that, and DE is another half of that. That's basically what the filtering capability of each of those filters are. Now, in terms of size, what that does for you is it determines how often you have to clean it, which is directly related to the square foot of the size. That's why sand filters, you end up backwashing them almost every week. DE is usually around, from a month to 3 months, and in a large cartridge, you can wait a year before you have to clean it. And it's directly related to that size, square foot size.
Right. I guess that's what I was, because the DE filters are typically 40 some odd to 60 some odd square foot. They as a cartridge filter. Only in Florida do they install 100 square foot cartridge filter.
Right. I would never do that. Don't ever do that.
Everywhere else in the world, they properly size their cartridge sizes, and then sand is just by a diameter of the vessel. Some of that is all rated on gallons per minute, which, as our discussion from pumps with variable speed, we're going to be running our pumps at a far lower than have ever been done in the past. Now, some people on this call may go, but I'll get algae if my pumps don't run fast enough, and we all know that's false. But that's another discussion. But again, that's why they're different sizes. My understanding is the maximum flow rate through them, right? And then also how long you can go between cleanings.
But wouldn't it be fair to say that for the larger the filter, the better? You can almost never have too large of a filter, and the larger your filter is, the less you will need to clean it. And also, should you ever get an algae outbreak, it will have a much better capability of filtering the dead algae in between cleaning sessions. So there seems to be very little downside to getting the largest filter you can.
Yeah, and Jim has the classic response to that on the forum. I think every time somebody comes up about that, Jim, go ahead, Jim. But I mean, as you said, bigger the better, right?
I always say bigger the better. I like to make fun of the people in Florida and tell them they live in the land of the dinky filter. And I don't know why it is. Maybe because a lot of them have shelters around their pool, screen rooms.
Right.
But when you look at pictures, I can almost every single time just look at a picture of their equipment pad and tell you whether the pool's in Florida or not.
Yeah.
Just based on the size of the filter.
Oh yeah, we see 20,000 gallon pools with 150 square foot filters or something like that. Some crazy. I mean, how often do you clean that? Oh, I have to clean it once a week. What?
I'd kill myself with that, dude.
That would be crazy, wouldn't it? So other than that, maintenance, general maintenance on all the filters. I mean, in general, we kind of already gone over some of those items, but let's pick the predominant one, a cartridge filter. What would be the typical maintenance process on a cartridge filter?
Well, I mean, once a year I take mine and tear it down and clean each of it. It's got 4 cartridges. Each one takes about 10, 15 minutes to clean. And that's it. That's all I do for that.
Some people think they need to soak them in materials. I mean, there are cases where TSP could help on.
Yeah, I think that depends on how much of like the suntan lotion you get in your pool. It's really, we're going to be specific to your pool. If you get calcium deposits on the filters. I have very high calcium water, but I've never had calcium deposits on the filter.
Right.
So I'm not sure how that happens, but I'm sure it does. And I think it's just mainly if you get getting a lot of oils, and if you spray down the filters and they don't look white, then you might consider soaking.
Right. The Diane pops in here and has asked about typical cartridge. How long should it last?
Well, my last one's lasted about 10, I think it was 9, 10 years.
It seems to be a round number, somewhere in that plus or minus a couple of years, around 10 years. Mine ended up being 7, and the tops were beginning to get a little bit flaky and things.
That's what happened to mine. It wasn't the media. It wasn't.
No.
I didn't get any holes in the media, but the round tops were cracking, and it looked, and the debris was starting to leak through, and that type of stuff. So
yeah, it's just time, right? You know.
yeah.
But we do see folks on the forum come in and say they were told by their pool guy that they had to replace them every year.
No.
Yeah, well, that's because he doesn't want to clean them.
He wants to sell them. Wants to mark them up and sell them.
Yeah. The only other real item on a cartridge filter to really even think about talking about is the gasket around the shell. Make sure that's lubricated. Be careful not to pull on it so you stretch it. Some of them have metal bands, like the Pentair clean and clears have a metal band that can get corroded or whatever and fail. What else was I thinking of along a cartridge?
There's a vent. Usually there's a small vent that has a screen around it that allows the air to get purged out, so you don't have to manually do that. That gets clogged too. So it's a good idea to clean that out.
Right, and I know on my Pentair top one, the valve that allows the air release, after 7 years now, the O-rings have started to get a little less, so I lube them suckers up and I run them, because you can pull it all apart and handle all those things. From a DE filter, and again, I think the only one that's run a DE filter here is Mr. Jim. DE filter, what's a general maintenance process there, Jim, and from your memory banks?
So for my DE filters, I think the grids, I just have the kind with the grids. And I suspect they're going to last about 10 years or so, maybe longer. I no longer backwash my DE filters. In fact, I've removed the backwash valve. It just goes, it's plumb just like a cartridge filter. And I open them up and clean them every 6 months. And that might sound extreme, but I don't get a tremendous amount of stuff in there. And I run low RPM, so I don't have a problem.
Right.
The large O-ring, I find, after a couple of seasons, it gets bigger. I know if you pull on it, it stretches, but it tends not to fit near as well. So it's worth the expense to me every 2 or 3 seasons to replace that large O-ring. I find that sometimes dirt can get up into the air relief valve on the top of the DE filters. And so when you're cleaning it, you need to wash that air relief valve backwards. So take water, flow it from the outside in the inside to blow all the junk out.
Great. I don't really have any knowledge on the quad DE, the hybrid DE. My understanding is they're kind of like a cartridge filter. You essentially break them down and clean them every time they need to be cleaned. So I think they're just a cartridge filter that uses DE from the aspect I know of them. So moving on to sand, again, probably about the biggest maintenance item for a sand filter from what I've seen is one, the valve, the filter valve problem with the spider gasket. If you have leaks while you're running in either filtering or waste or backwash or whatever, you'll see that spider gasket has a problem. And also deep cleaning. Again, none of us have a sand. I've never done it, but there's the deep cleaning of the sand every year is kind of discussion. Because one, if a person uses clarifier or flock, which the forum recommends you don't use, but when you do, you will mess up that sand media. The one thing about sand that I think I want to voice here, and again, none of us have one, but you know, our forum owner, founder, co-founder, Dave, always spouts that sand never needs to be changed. And that's true. If you properly manage it, sand should never need to be changed. Got a couple of quick questions here on chat, and then we need to move to heaters for a few minutes here. Let's see, with a cartridge filter, do you need to install a bypass to allow vacuuming to waste? Well, if you want to vacuum to waste, you will have to install a bypass for a cartridge filter. To be honest, I've never vacuumed to waste personally, because if you keep your chemistry proper, you don't need to vacuum to waste. But yes, you would have to install some form of bypass, typically a three-way valve between the pump and the filter will allow you to do that. Diane brings up smaller DE filters have a bump mechanism. So these filters don't have a multi-port and have to be opened up and hosed out each time. And that's true. They're not all, and I think Jim, you may have mentioned that. I don't know if yours had the bump type valve or not, but what she said was that, you know, many of them you can't, all you can do is backwash and filter, and that's it. And so, you know, that's actually a real problem that pops up with DE filters on the forum, in my view, is that somebody does get algae with that kind of filter and that kind of valve, they're in for a ride. I mean, they're cleaning, they're bumping that thing every 10 minutes and cleaning it. It's a mess. So let's move away from filters here, and we'll just spend our last 10 minutes or so on heaters. You know, my understanding is, you know, I have a natural gas heater. I know there's heat pumps. The gas fired are either propane or natural gas. Heat pumps are electrically driven. We won't get into solar, which I know Mark has a lot of involved in with, but we won't get into the solar into the business. But Alan, you live in the Northeast. Give us some discussion around heaters and the different types and what we see on those.
Well, as you mentioned, you know, for heating a pool, you basically have two choices, which is gas heat or a heat pump. And the number one question comes down to, what energy sources do you have in your house? If you have natural gas, then a natural gas heater is often the least expensive to install, and you know, often the clear-cut winner. If you don't have natural gas, then you know, everybody has electricity, and you know, a heat pump can be a very good option. In terms of energy efficiency, you know, a heat pump is more energy efficient, it's greener, but it, you know, this is an answer where it's really, it depends. It depends what environment you live in, you know, whether you're a northerner or a southerner. It depends not just on your local temperature variation, but also on your local humidity. Heat pumps are most efficient in warm, humid areas, not in warm, dry areas. So it can have a very local, the answer can be very local for a person between a gas heater and a heat pump, depending upon the environment, the energy source that they have, and what they intend to heat, whether they intend to heat just a pool or a spa. You know, I describe a gas heater as an on-demand heater. You know, gas heaters throw off enough BTUs, enough heat. You can heat a pool and particularly a spa fairly rapidly. A heat pump, not so much. you know, there is no substitute for BTUs. And in general, my recommendation is always buy the most BTU heater that you can, that fits into your budget and that your gas line or electrical service can support. In my view, there's almost never reason to buy a smaller BTU heater of a given type. So there are all of these variables that people need to assess what they have. If you have a spa, if you have gas, that's probably the thing to do. If you don't have gas, you know, if you don't have natural gas, there's propane. Propane costs 3 to 4 times what natural gas costs. Then there's a heat pump. Heat pump is good for maintaining heat in a pool. It generates heat slowly over a long period of time. You need to run your pump and your heat pump during that time to produce the heat. But if you want to raise your spa by 20, 30 degrees, a heat pump's going to take a while. Mm-hmm. So those are all the trade-offs and considerations. And that's really where, you know, more than anything, that's where the form comes in to describe, you know, where you live, your location, the energy sources, the type of pool spa you have. Let's talk about it and we'll try and guide you and help you.
Right. I know the wiki has some really good discussions and articles in there. And also I know you point folks to Pentair, if I believe it was Pentair that has the heat pump calculator.
Now Pentair, Hayward, there are lots of calculators for both gas heat and heat pumps and looking at the energy trade-off between the two to use to help you be more informed about what will it cost to heat. These calculators they ask you for your zip code. So they look at your local climate and factor that in, and by month tell you, you know, the calculator may say in January, February, you know, you just can't heat your pool. It will not reach this temperature that you're saying. But there's the analytical capabilities to help you make those choices.
One thing I don't think they take into account is that, and I've seen this on the forum, is that heat pumps tend to have very high head loss. And so if you're comparing energy use, you have to take into account that fact that even if you have a VS pump, you're going to be running it at a much higher RPM than you would be for natural gas. I don't know why they build them this way, but for some reason, most of them seem to have this particular limitation. So it's one consideration as well.
And I believe, Mark, that's why, I mean, I know Alan is always the forefront on this, is talking about putting in bypasses so you only run it through your, you know, most of the natural gas fired normal heaters have kind of an internal bypass system.
They have an internal. Yeah, I don't know why they don't do that for the heat pumps.
But I don't know that. Alan, do you know that? Do the heat pumps have the internal bypass also?
You know, heat pumps are heat pumps came from air conditioning technology and for heating and cooling houses. And I think that the engineers who worked and designed that never really owned a pool or understood a pool and how it was going to really be used. Because you look at things in the heat pumps and you wonder what they were thinking in terms of, you know, maintaining them and how they operate.
You know, Diane brings up, you talked about HVAC. Diane brings up a good point. There are heat pumps that are marketed now that they'll chill and heat, right?
Yeah.
Well, you know, a heat pump, you reverse a heat pump and you have a chiller.
Right.
So, you know, a heat pump can heat your pool or it can air condition your pool and provide cooling. The issues come in controlling it, and the automation vendors have had issues with how a heat pump switches between heating and cooling, and the thresholds that how many degrees difference before it starts cooling. There've been a lot of bugs in the system that the game worked out, but that technology is still a little bit quirky.
Yeah. Real quick here, Woody also put up a question about the fact that the cost to run a gas line, say you need to run a new gas line for your gas pool heater, can cost as much as the heater. And that's true. I mean, I think ours was, it was quite expensive. I mean, we had to run our line probably about 60 feet. And it, but this was 7 or 8 years ago. And I still think that was well over almost $1,000 to run it. And I think today's world, it's even more than that. So that's for people to keep reminding of themselves. From a troubleshooting standpoint, anything, we've got a few minutes left here, literally 2-3 minutes. What are some the main troubleshooting aspects of either a heater or heat pumps?
Well, before we get into any of the weeds, and we can clearly get into that,
No, we
I'll
don't
make
want
a
to do that.
comment about heat pumps that again, like I said, heat pumps are really a strange animal. With gas heaters, it's very well understood. Gas heaters, you need air, fuel, and spark, and you should get heat. It's not very complex technology, and pool service companies have maintained gas heaters for years, and they usually have people who can work on it. We've seen a good number of members on the forum who bought a heat pump, and when it failed and they went to get it serviced, they discovered they couldn't find anybody in their local area who would work on it, because the pool service company says, we don't have anybody who understands heat pumps, how to work on it. They call an air conditioning company, and the air conditioning company says, we don't work on pool stuff. They even call the manufacturer, whether it be Pentair or Hayward or Jandy, who says, we don't have anybody locally to work on it. And we've seen people really get stuck with not being able to get service for their heat pumps. So I now tell people, when they ask what brand should they get, I say, find out what brands can be serviced in your local area.
Good
When
idea.
it comes to the gas-fired heaters, again, I think we want to, because we need to wrap up here, troubleshooting of those, there's a lot of good information on the forum. We've got some members on the forum that are very quick to respond and to any of your questions, or those folks out there listening to this. If any questions, there are a number of different sensors and things that can go bad on a gas-fired heater. The internal bypasses can go bad, things like that. Again,
Spiders in the Venturis.
spiders in the Venturi, the rats getting in and chewing up all the wiring and et cetera, defecating on everything and shorting out all the control boards. So I really want to make sure that the folks that are listening to this realize we didn't leave much time for heater discussion, but to be honest, it's so specific. Go ahead and post on the forum and just be aware that most pool owners probably should not be doing a lot of work on their gas-fired heaters. There's a lot of safety concerns when it comes to that. And so just let's keep that in mind. So, well, we're at our 1 hour time commitment. I really, really appreciate you three gentlemen helping me out with this. I think we generated some huge information here for our members and for those that watch this video, especially around pumps. And I think we need to advertise this video when people have questions about these. So I'm going to go ahead and turn off the record here, and we can just then in general have a discussion a little bit for a bit at a time. So here Here we go.